right? All right. This is Linux File System Forensics. My name is Gary Smith. I'm a cybersecurity analyst at Pacific Northwest National Laboratory. There's our sticker down there in the bottom. We're over on the dry side of Washington, where we get 6 inches of rain a year if we're lucky. This is Linux File System Forensics, the who, what, when, where, why, and how of investigating a Linux disk image. So, what kinds of analysis can you do on a system, regardless of whether it's a Linux system, a Windows system, a Mac? Well, there's basically two kinds. There's live analysis, where you're physically or by some connection on a live working system and you're doing some type of magic on it to determine, has an incident happened, do we have a breach, who's logged on. You're trying to capture volatile information about what's going on the system to make some sort of problem determination. Or you're doing dead analysis, where you've got a disk image or a series of disk images, and you're asking those questions again of who, what, when, where, why, and how to make some sort of determination about what the history is. Now, there's live, there's dead. Who's a Walking Dead fan? Walking Dead fan? Okay. I've kind of been wondering if there's maybe a third kind of analysis where the system is dead, but it's still sort of alive, and you're trying to figure out what's going on, and you're not really sure, and it's eating your brain. I've seen this happen when a system has gotten into sort of a locked up state, and you can move the mouse, and then the pointer moves, but you can't do anything else, so maybe at that point it's a zombie and whatever. Linux file system, Linux forensics is different from Windows. Obviously, Windows is not the same as Linux, and Linux is not the same as Windows. But there are things that carry over as far as terms and concepts from one to the other. For instance, Linux doesn't have a registry. Windows does. And a lot of what you do in Windows is you scour through the registry looking for important information, artifacts, keys, stuff like that. You don't have a registry in Linux, but you do have similar concepts of what you're trying to do. So what we're going to be doing in this tutorial is we're going to be looking at a disk image of a potentially compromised Linux system. We will be going through trying to find the 5 W's and 1 H through looking at a timeline for the system and for a file system. We're going to be extracting artifacts from that image to provide evidence and reach a series of conclusions about was the system compromised, how was it compromised, what went on. Okay, so we have a scenario base for this. The scenario is that I'm a forensic examiner, and this company called Premier Fabrication Engineering, PFE, they think that one of their servers, their primary servers, PFE1, may have gone through some kind of a compromise, been involved in an incident. So they have engaged me as a forensic examiner to determine what has happened. Was it involved in an incident? What was the nature of the incident? What all happened? And they've also asked me to provide some recommendations for them on what they can do to mitigate factors if there was a breach. So, I'm going to conduct an investigation, and I want to do this on the disk. I want a disk image of their primary server, and I tell them, I want you to send me a disk image of the primary server, and they say, no sweat, we'll send you a USB. Great. So I wait. Now, to do this analysis, I'm going to use a VM running the SANS SIFT workstation distribution. SIFT, I've forgotten what SIFT stands for, but it is a whole bunch of free open source forensic tools that SANS provides. You can go out to their website, you can download it, install it. It's got a whole bunch of forensic tools in it to make a forensic examination very easy. Now, some of you may be asking, well, why is he using SIFT? Why doesn't he use Kali? Well, you could, but SIFT and Kali are sort of on opposite ends of the universe. Kali you use to break in, SIFT you use to find out how they broke in. Okay, the USB shows up, I get it, and I start looking to see what's there. Well, I look at the USB drive, and it's not what I think it is. It's not a disk image at all. Instead, it's a bunch of VMDKs from their private cloud. Uh-oh. Well, it's not what I thought. This sort of thing actually happens a lot when you're doing forensic stuff. You say to the client, send me this. They send you something. It's not what you were looking for. So, I didn't get exactly what I was looking for. What am I going to do? Well, number of possibilities. Could always go back to the client. I could go back to PFE and say, hey, look, you didn't send me what I needed. Send me this instead. Well, I don't really want to do that because I don't want to appear to be a whiner. It's not good in an early engagement to be a whiner to your client. So I'm not going to do that. I'm not going to ask them to send me something else. Another possibility is they sent me a bunch of VMDK, which is a dump of their ESX server. I could always plug that into VM Player or something, other kind of virtualization piece of software. Run that VMDK, use the programs that are on that VMDK to do the analysis of the system itself. Well, I can think of 3 reasons not to do that, at least 3. One, if I fire that VM up, that's going to alter timestamps, that's going to alter file information. I don't want to do that. Really don't want to do that because that's going to just muck things up and that's going to make it more difficult to determine what actually happened. Another thing is that this server is believed to be compromised. So therefore, every file, every program has to be considered as suspect. You don't know what may have happened. You run a program, which leads me to number 3. The native programs are probably compromised. We believe them to be compromised. This is not a court of law where you're innocent until proven guilty. This is the other way around. This is French court. You're guilty until proven innocent. Big difference. We have to assume that everything is compromised, and you run a program on that potentially compromised image, and it may have unforeseen consequences that you didn't think about. That program that you're running may be going out to some command and control system out there on the internet and say, hi, I'm alive now. Tell me to do something. Not good. Possibility number 3. There's a set of utilities that you can use to access stuff inside a VMDK. But that's another level of indirection, and I'm not a very good typist, so that means more typing, which leads to more errors. A better approach is door number 4 down there. I'm going to convert the VMDK into a raw file, a raw disk image. And then I can plug that into the SIFT workstation and analyze it from there. So, reasonably easy to do. There's a program called QEMU, which is part of the distribution, that will allow you to manipulate images offline. So what I do is I convert it from a VMDK to raw format. That's what that does. QEMU, the operation is convert from VMDK to raw, the image that they sent me, where I want it to go. And that goes on and on and on and on. And that actually takes a fair amount of time. And this presentation is sort of like a cooking show. If you ever watch cooking shows, everybody watch cooking shows? I love watching cooking shows. The guys and ladies that do the cooking shows are just fantastic. You learn a lot on there. But if you ever watch a cooking show, you know that they've got 30 minutes to cook like beef bourguignon or roast duck or something like that. And they go through the process of setting the whole thing up, and then they shove it in one, they have a double oven, they shove it into the top oven, and then they open the bottom oven, which has the completed thing in it. Well, I've done some of that in here so that we don't have a lot of time wasting things going by on the screen. So this is somewhat like a cooking show in that. Yes, sir?
I just wanted to ask, are these slides going to be made available?
Oh, yes. Okay. Yeah, they will be made available. Yep. If not, email me. I'll be happy to send them to you. Okay. I've now got a raw image, but let me talk just a few minutes about Linux file systems. Generally, you install Linux, and you get either an XT2, XT3, or XT4 file system. Red Hat has now made their standard XFS with RHEL 7. But in XT2 and XT3, you had 3 timestamps. Modification, when was the file last written to? Access, when was the file last read? And change. What's this change business? Didn't we already take care of that with modification? No, not quite. Change means something like, who owns the file? Was the file renamed? Or did the permissions change? That's what they mean by change. That's usually abbreviated MAC, Mac. Unfortunately, Mac is very overused in computer stuff because you got, okay, I got a Mac up here that's a laptop. It has a MAC address, and MAC also stands for something in security called mandatory access control. So MAC gets really badly overused, but those are the 3 things that all the file systems have: modify, access, and change. XT4, big advance. The file birth time. When was the file created? That got thrown in XT4. That's really great from a forensic standpoint because now we can know when a file was actually created. Dan Farmer and Vierzy Vanima, who also wrote Postfix, wrote this book. It's a good book. A little bit about the timestamps because we will be talking a lot about time here. When you're talking about a directory, the modification time was when something happened to the directory's entries, like it was renamed or moved or something like that. For just a regular file, it's when it was last written to. Last access, or when was the last thing that was read. For directories, when it was searched. For a regular file, when it was opened up and information was read out of it. Status change, basically, we talked about that. Deletion time, I've never really found much of a use for that one, but sometimes that does pop up. Creation time, XT4 records when the file was actually created. Where is this information kept? This is what's called metadata. It's data about data. And different file systems do this in different ways. In Linux, it's kept in something called an inode, information node. When you scramble the bits up on a disk and create a file system, you create inodes. And they're sprinkled around in various portions of the disk. They have a fixed size. To give a complementary idea back to the Windows world, there's a thing in Windows called the MFT, the master file table, and entries in the MFT are sort of like what an inode is. If you want to look at inodes, you can do ls-i on a file, and that will tell you the inodes associated with the file. And then you can use the istat command to get information about the inode. This will show you the metadata attributes of the file. For instance, it'll show you the timestamps. It'll show you the size in bytes. It'll show you who owns it, the group and ownership, and other information. Okay. So, this is to remind me that it's time to do the demo. CSI fans? CSI fans, lots of CSI fans. Why do I have the CSI, why do I say this is the CSI effect? This is really bad for forensic examiners. CSI has really hurt forensic examiners because judges, juries, lawyers, the common man out there believes that you can do an entire analysis in 45 minutes or less. Doesn't work. Can't do that. Really doesn't work like that. Okay. So, almost forgot. I need my crib notes. Okay. Okay. All right. Yep, okay, cool. Now let's do this and let's manipulate the mouse over. There's that. And hey, okay. Okay. And there's that. Okay. All right. There's my converted image. Okay, so now I need to figure out some properties of this. What have I actually got here? There's a command called mmls that will tell me information about that raw image. Because I've got to manipulate the file system. I need to know some information about that file system. Now, this is like a partition table dump if you've seen that through FDIS, but it's similar. Right here, it's 1 sector long, 512 bytes. That's my master boot record. I don't need to worry about that. Master boot record, that just says go boot. Then I've got some unallocated space here because that's just the way it works. But look here, starting at sector 2048, I have a Linux partition. Yay! Good deal. And then some stuff to make it end on a nice boundary. I got a DOS partition. That's my boot partition. I got some swap space. Great. And I know that my Linux, and I know this is a Linux partition because that's the partition number that you do when you do an FDisk. This is great. I'm happy. You know why I'm happy? Because they're not using LVM, Logical Volume Manager. Everybody's going, Logical Volume Manager, oh no. Sign of the cross. Stay away. If this did have LVM, yeah, I can still manipulate it. It just takes more manipulation to do it. But great. I've got a, I don't have to worry about that. I'm interested in this right here. So, what I'm going to do now is I'm going to use the file system stat command, and I'm going to point it at an offset of 2048, which is where my Linux petition starts. I'm going to get some information out about this that's going to help me in my analysis. Okay, great. Right off, I see great information here. It's an XD4 file system. That means I can get creation times out of this stuff. The next two lines. When was it last written? When was it last file checked? So I know that. That will help me narrow down any dates that I want to look at on this thing. It was you mounted properly. That means that they just didn't turn the machine off or pull the power cord when they shut it down. Also, it was last mounted on slash. So I do have the root partition. My earlier analysis with MMLS led me to believe that starting at 2048 offset sector was where the root partition started. That is the root partition, so that's great. And there's a whole bunch of attributes there that journaling is on. Some other stuff that's not really important, but the important stuff is that it was you mounted cleanly. This is the slash partition, and I've got some idea about dates here. Now, as it turns out, the good folks at PFE have told me that they think the machine was compromised sometime between March the 1st and March 31st. So that gives me kind of an idea of when the bad events may have happened. Now, I take this with a grain of salt because Verizon publishes this thing every year about intrusions. It's called the DBIR. You can Google for it. One of the things that comes out of that is how long it takes an entity to figure out they've been compromised from the time the compromise occurred to when they figured it out. Anybody want to take a guess at what the average is?
6 months.
205 days in the latest one. That's 7 months. That's how long between the time the intrusion occurred and they figured out, hey guys, something's wrong. 205 days. That's what's called dwell time, the time that when the breach occurs to figuring it out. 205 days for the average. That's a long time for bad guys to be in your network messing around.
Is this monitored or unmonitored, or does it really matter?
Does this, pardon?
Like if the server was compromised, would that server be monitored or unmonitored or managed or whatever? Or does that really irrelevant?
I think she's asking
Yeah.
about if it's got tripwire or OSSEC.
Oh, no, none of that's on here.
Okay.
Yeah.
That's what that's for.
Okay. Okay. I know some information about when a time span to look over. I've got information about what the client says should be the actual time. Okay. Now, I've got information here, and I want to mount that image so that I can do stuff on it. Now, I could be real slick Linux geek and take that information and figure out how to mount all of that up. Or I could get a program to do it for me. Well, part of the distribution is this program called K-Part-X. It'll take that raw image, look at it, figure out where things actually start for me, and create loopback devices for each one of those partitions that I can then mount. So I don't have to go through and do complex arithmetic to figure out offsets and where to mount the thing up and where the super blocks are and all that happy stuff. So a couple of options to use with K-Part-X that are relevant are create a read-only loopback device. I do not want to write back data onto my forensic image. That will potentially get me in trouble if I'm called in for to do testimony. There are lots of sharp lawyers out there who do understand some of this stuff. And one of the questions they might ask is, how do you know that you didn't write something back? Well, I mounted it read-only. Oh, okay, on to the next question. Part 1B for verbose, and what does the R option do? I forgot what R does. It's going to add the mappings, the partition mappings, to the system.
What were those switches? Minus R, minus V, and what?
A, RAV, like remote automatic vehicle.
I have a question. So
Yes,
I know
sir.
that you skipped over LVM, but the way you're mounting this, like, I just wanted to make sure, is there any, like, risk to, like, if I find a volume group on a disk, like, just using the LVM tools to, like, doing this, getting it mounted, and then using LVM to look at the logical volumes? Does it write anywhere?
Oh, yes.
It does, okay.
Yeah. LVM is going to update stuff.
Okay.
So if this were an LVM, I would have to do some more work to get to this point, but I don't have that problem since it's just a flat partition. Yeah. LVM the LVM stuff does update stuff on the Vive. Yes, sir.
Could you bump up the font size just
Yeah, sure. Let's
Say
see.
black on white with bigger font size, maybe?
Okay. Let's see.
Somebody else mentioned it, I was going to.
And
That's how you get
Perfect.
together.
okay, there's that. Let's see. Mouse. Okay. Oh, no, that's not it. Okay. Let's see.
Maybe go under profile and invert your colors.
Profile images.
Gary, just
Colors.
tell us.
Let's try.
Black on white is, there you go.
Ooh, much better.
Yeah.
Okay, is that better for everybody?
Yes.
Thank you.
I like. I guess it shows being where I came from, because for some reason or the other, I like green on black.
Traditional.
It's traditional, yeah. But yeah, for projecting like this, this is better. Everybody here, I'm sure, has seen The Matrix. You do realize that stuff inside the matrix, when they're inside the matrix, that was shot through a green filter because the Wachowskis wanted to go back to the old days when it was green phosphors on a black background. Yeah, that's why everything's green when they're inside the matrix. When they're not in the matrix, they shot it through a blue filter to give sharper contrast. Okay. All right. Forgot. Sudo. Sudo. Bingo. Okay, it's created a bunch of loopback devices, and this one is my main partition there. Now, all I need to do is get that mounted. Bingo. I've now got my raw partition, the raw disk file, mounted up, and there's all the stuff under there, like we would expect.
Does it just create the loopback device in dev? Or like, is it a subdirectory in there?
kpartx actually creates it in dev mapper.
Dev map.
Yeah, it actually creates it in dev mapper, and it creates a partition. It creates a loopback device for every partition that it can see.
Okay.
So there were 3 on there. There was the root partition, there was the boot partition, there was swap partition. So it creates 3 of them, and in that order. Okay, so now I've got it mounted. Okay, let's get rid of that. Okay, I got it mounted. Now here's where you can sort of see a difference between 2 different types of forensic examiners. There's one kind of forensic examiner that they get this mounted and they go, oh boy, I got file systems and files and all this stuff. Let me just start trailing through it and pick up stuff. Well, that's one way. I call those people that do it that way creepers, because they just kind of creep through the file system looking here and there for whatever interesting stuff they may be trying to find. They've got their own little kind of idea about how they should be, of where things are and where things are located and what things are important. That's great. That's one way to do it. The problem with that is that if you are ever called in to give testimony or to tell about what you've done, and you're up there on the witness stand or talking to the corporate lawyers, what'd you do? Well, I kind of just rolled through things and I looked at different things out there and I found this and I found this and I found this other thing, and this doesn't look good. This doesn't look good. This doesn't answer the primary questions that your client is looking for. The who, what, when, where, why, and how something occurred. What you want to do is you want to create a timeline of events that happen. Now, there's any number of ways that you could do this. You could do this by hand, but there's another way to do it. It turns out there is this great set of tools called Plaso, P-L-A-S-O. It was originally invented by some guy in one of the Scandinavian countries, and it's been tremendously improved on. It works, it understands Linux, it understands Windows, and it understands various output formats. You take your raw image, submit it into this thing called log2 timeline, and that runs through the file system, looking for different things based on what you tell it, what type of system it is. For Linux, it understands things like log files, wtemp, btemp, Apache log files. It understands things having to do with browser log files. And it creates a database based on that information that it finds. Then you can feed that into another program called psort. Psort will transform that database into some other format that you can use and manipulate. For instance, you can have it put out a CSV file, comma separated variables. Or you can have it spit out a Excel spreadsheet type file and look at that. If you're going to go that route and use a spreadsheet to look at this information, I highly recommend that you spit out the Excel file rather than CSV. It's much faster in looking through it. You can get a MySQL database out of it. Another possibility that I particularly like is it will write directly to an Elasticsearch instance. Elasticsearch is great. It is one of the best indexing things on the planet, and it's free. It is free. You could, if you wanted to, take all the Star Trek episodes from all the scripts from the original Star Trek, feed them into Elasticsearch, and then say, Elasticsearch, what episodes did Dr. McCoy say, I'm a doctor, not a blank? And it would tell you. That's how good it is. Okay, so this is the part of the cooking show here, because this actually takes a fair length of time to go through and create that database and then spit something out into Elasticsearch. When you look at the slides, you'll get the command. But I've got the database, the timeline spit out into an Elasticsearch instance. And there it is. This is Cabana. Cabana is the interface to Elasticsearch. It lets you create dashboards, visualizations, all kinds of neat stuff based on the data that's in Elasticsearch, and you can pull it out. Now I've defined something, you can get really fancy with Cabana. I've done that at something at work, but for this, just doing this forensic examination, I got something very simple here. I've got the time, I've got what created the, some information about what created the entries, who reported it, and the actual message itself. But also very important is I've got a bar chart up here showing me when stuff happened. And I can see that probably they were right, because I've got this big bar right here of activity where things were generating lots of logs. So what I can do, I can go over here and section that off. And it thinks about it. Wow, got a whole lot of activity here. That bears investigation. Let's go over here and section that little bit out. And we think about it. Oh, okay. What does this look like? This looks like an install, doesn't it? Or an upgrade. And this goes on. Yeah, this is a lot of stuff. This goes on and on. Yeah. Yeah, this looks like somebody was doing an upgrade. So that's really not that terribly interesting. Now, there is the possibility that somebody's being really sneaky about this and they're doing an upgrade, and then while that upgrade's going on, they slip something in under the cover. There is that possibility, but we're not going to go down that path unless we have to. So, yeah, that big spike there wasn't terribly interesting. Now, in the Windows world, if you use a program to do a forensic examination like FTK, Forensic Toolkit, or Incase, or Autopsy, you index your image and you want it to go through and find keywords of interest. For instance, if you're doing a fraud examination, you're looking for credit card numbers. Credit card numbers for each of the different credit card companies have a particular format. Each one is slightly different, and you can use regular expressions to find instances of those credit card number types. Email transactions, that actually name at something dot something dot something. Index for those kinds of things, looking for email stuff. Cases of inappropriate use. That's always a good one. That's a good, nice blanket term for things usually involving bad images. So you're looking for JPEGs, GIFs, bitmaps, PNGs. I don't know of anybody that does bad images in PDFs, but I'm sure somebody does, but you can index for those too. So we're not really doing that kind of analysis on this Linux system, but the idea of using keywords in our search is what we want to do now. So we're going to take the customer at his word and assume that it is from the 1st of March through the end of March. And let's cut that out. 23:59:59. Let's go ahead and bring that up. And it's thinking about it. Okay. Do I have this right? Okay. All right, there's our big spike there. Keywords. What about apt-get for doing system management? Let's search for instances of doing apt-get. See what may have happened there. Think. Okay. Okay. There we are. Looks like there's more stuff having to do with the install there. Okay, well, that's all stuff having to do with that installation. That's not terribly interesting. Actually, I goofed that. I should have. Really should have done that. That's better. Okay. That's all that installation. That didn't really tell us anything. REPORETER : what's another function that system managers frequently do? They add users. Well, that's a good possibility. Paydirt. Paydirt. We see that on the 5th, somebody ran user add, and they tried to add VBox add. Well, it's not terribly useful. Looks like somebody installed SSH here because they created the username SSHD, and it's set to no login. Oh, but this is interesting. Somebody created a user called John N. And they created a home forward and set the username to bin bash, the shell to bin bash. That's interesting. We can see some activity now that looks interesting. Okay. Another possibility. What else does system managers frequently do? Sudo. Well, keep that thought. Keep that thought. Well, they created a user. That probably means that they set a password for that user. I sure hope they did, if they're doing good system management. Did I spell it right? I got the right number of S's. Think. Okay, cool. Sure enough, they changed the they set a password for this username, John N. This is just keyring stuff. That's not important. But look at this. They changed the password for Whoopsie. Whoopsie's a system account. Why would somebody want to change the password for Whoopsie when ordinarily you don't log in through Whoopsie?
Elevation of privileges?
What's that?
Elevation of privileges?
Good point. Exactly. They did the same thing here for LightDM. What's LightDM? LightDM is a display manager. Does it ordinarily log in? Nope. Backdoor. Somebody's created backdoors in this.
If we could look at user mod and see if they changed the shell.
Pardon?
Could we look at user mod and see if they changed that so they actually could?
We certainly can. USERMOD. Yeah, they changed SSH. But that's a good thought. That's a good thought. Very good thought. Yeah.
If they changed the password for the SSH daemon, damn.
That would show up when we look for password, and that didn't show being changed.
I mean, it says change
Um,
SSH password. Was that activation?
That's part of the activation.
Okay.
That's part of the activation. Let's see. Did they delete any users? Well, this is kind of weird. They created user John N, and then user John N got removed. But we see that it got added back. So they created user John N, deleted him. I guess they didn't like the way it was set up, and then added him back in. That's kind of interesting. This gentleman over here suggested sudo. System managers run sudo a lot. Very good thing to search for. How are we doing for time? Okay. Oh, all sorts of good stuff. Okay. Let's see what we've got here. All right.
A single word search?
Pardon?
You do a
Oh yeah, you can do a multi-word search. You just got to make sure you enclose it in quotes. In fact, we'll get to that in a minute. So we see that this username John, user John, is acting like the system manager, because here he does an apt-get y upgrade. So that's going to do all that nice happy upgrade stuff.
Wasn't the other user we found not John, but John N?
John N. Yep. Well, yeah, we found him. They got created along the way. Let's see. Yeah, he's doing apt-gets.
This all looks like the legit stuff from when we were.
Yeah, this all looks like reasonably legit stuff here. Yeah, he's installing SSH here. Okay, what else is he doing? Okay, just basic session stuff. Let's see.
There he is. There's two different users there.
Yeah. Yeah, there's John N.
That one's cool.
Yeah. Oh, now this is interesting here.
Yeah.
Look at this. We've done a sudo on this particular directory, bin bash, downloads Jingyi Quan. What's Jingyi Quan? It's a Chinese form of martial arts, similar to Kung Fu, similar to Tai Chi. Why is John installing potentially a Chinese martial arts program on the company's main server? Does anybody think this is kind of weird? Yeah. What else has he done here? Oh, he's in this directory and he's done an install. He's installed the program. Well, that's kind of weird. What's this Jingyi Quan thing? Well, let's go back up here. Let's just search for instances of that string, because this is starting to look interesting. Ah, bingo. Now look at this. Remember I said that Plaso, the whole Plaso suite goes out there and can understand Firefox history, browser history? It found this as Firefox history. So we've got, oh gee, they went out to Google looking for a rootkit with this name. Well, this looks pretty bad. This isn't so great. They found Jingyi Quan, and although this is hard to read here, they found it on Packet Storm Security. They actually downloaded it. Okay. Now,
What if you had done a string search for rootkit right from the beginning?
we could do that.
Would that have come up with all of that?
Potentially, yeah, because that's a string. But the thing to do, when you're doing this kind of thing, you need to be methodical about it. And I'm just searching for just normal activities that a system manager would do. But yeah, I found rootkit now. Well, that's really that's very interesting. Okay. We see that this rootkit got downloaded from Packetstorm to the home directory of username John. But who did this? Did John do this? User John do this? The username giant John? Well, we don't have really a clear indication of that. So we need to track that down a little bit further. It turns out that Firefox, and Chrome too, as well, keeps history data in a SQLite database in the user's home directory. So now what we need is we need to be able to look at that information to establish whether or not that was really useful. Now, anybody's familiar with SQLite, there's an easy way to get this information out. There's a program it's a nice GUI program called SQLite Browser. It's free, you download it, you point it at a SQLite database, and it will show you the records in that database. Now, I have done that already in this analysis, but I'm going to use, let's not do that. I'm going to use a web version of it because it looks better on the screen than what you get from normal SQLite. And we're going to open a DB, and we are media. Is that right? No. Crud.
It's not in the hidden file in their home directory?
What I need to do is I need to go to that mount. I need to go where it's mounted, and then go in the home directory of that mount under that mounted place. And
If you do an LSPLK, it'll show you where. Or
pardon?
Terminal and type mount.
That's exactly what I'm going to do. Did I not mount it? Oh, that's right. I did mount it on this particular machine.
Oh, because you already had it in Elastic.
Yeah, I forgot to mount it on this one.
so
Actually,
is Plasso another distribution?
no, Plasso is a program. Actually, here, since you asked that question, and this is coming up in the history, this is what you use log to time, tell it that the start at slash, that the parsers are Linux, what you want to create, the file name that's going to be the Plasso database, and then where to start from. That's the Plasso command. That's the log to time. That creates the Plasso database. That's the log to time. That's going to be the input.
Control R mount?
Okay. Now, I mentioned that I'm going to send it directly into Elasticsearch. This is the command that will do that. psort, output is Elasticsearch, the raw fields, and I just give it an index name that's going to go into Elasticsearch that's going to be for this particular case, and then my Plasso database. And that will read through the database and send it directly into Elasticsearch, the Elasticsearch instance. I don't have to do anything else. Okay, let's see, where's the magic command here? I don't know what I'd do if I didn't have command history. Okay. Let's see, where do I? Let's see. It's also hard to type when you've got your neck bent. Okay. Oh, okay. Typing. One of these days, we're going to all go up in a nuclear fireball because somebody at NORAD didn't type the command correctly. You think I'm kidding? I also have concerns that we're
Should it not be in read-only mode for reading the SQLite database?
pardon?
Should it not be in read-only mode to read the
I couldn't
SQLite?
find any matches for that.
No, we do want it to be read-only because it's just going to read. It's going to read the
Okay.
read the file, read the raw image, and there's
The
there's
Pardex man page says that the -r flag is for read-only.
the pardon.
-r.
Yeah,
Okay.
You
Yeah.
didn't have it in there.
I thought I did. Okay, that's bad typing on my part. There should be a -r there. Okay. Okay, now we're cool. Okay. Let's go back over here and okay. DB and there, and we're going to do home, and we've got 2 users there. There's John N, the one, the unusual one that created, and John, and
Looks like John N's is a dot file too.
yeah, yeah, that's a very good point. What's special about files that start in with a dot in Unix? It's hidden. You just do ls directory name. It doesn't show up. You have to use the -a to see it show up. Now, where's the? Okay, no, that's not it. No. I need to enable the option that allows me to, no, let's go ahead. Open. Let's see, okay, I think I already got this. Okay. John I's profile. Okay. Ah, there it is. The .mozilla directory is where it keeps its stuff. Okay. Keeps it under Firefox. And it randomizes this name here, default. And the, let's see, where is it? Default dashes, here we are. There we are. Places.SQLite. That's the actual name of the database that Mozilla keeps it in. We open that up and should think about it for a while. Okay, let me try this again. Okay. There we are. Now it worked. Okay, and the particular schema that it keeps it in is over here. And Mo's places. Okay. There's some of the usual stuff that you get. But now the reason for doing the web version, that's the reason for doing the web version is I can click on it and it brings it up all nice and pretty. And that's not terribly interesting. Bookmarks folder. And, here we are. Sure enough, searching for Jingyi Quan rootkit on Google. This looks very damning. We now know that user John searched for a rootkit. And it looks like he found something. He found something on Packetstorm, packetstorm.com. He found Jingyi Quan Linux rootkit.html, which is a web page. Went further, found the tar file. Downloaded it. And that's the end of that. Now, let's see, where did our mouse go? Mouse, okay. Hello, mouse. Okay. Let's do this. See this number? Big long number. That's an epoch time in Unix. Doesn't mean anything terribly interesting in this, but let's go to a nice website that will convert epoch numbers. Let's go back over. Let's go back over here. And copy. Forgot to point out something when we were back over looking at those records in Firefox. Paste, convert. Oh. That's not.
March 6th.
Friday, March 6th.
That's. That should have converted to something else, did I not? Pardon?
Yeah, no, it's right on assuming timestamp.
Friday, March 6th.
Right to load that.
Oh, okay, I'm sorry. Yeah, there it is. Okay. There's the date there that the download actually occurred. Now we can go back to our Cabana instance and
I think the Cabana stuff's in your time zone, so.
yeah, I'm not sure why the time zone got screwed up.
It looks like below it says your time zone, and Thursday, March 5th sounds about right.
Yeah, okay. I'm sorry. I'm sorry. GMT. Yeah. I'm sorry. I'm not looking far enough. Yeah. Anytime that you're doing timeline stuff, make sure you get the time zone right. That's thing number one. Ask the client what time zone they're in. That's very important. Rule number two, never do anything in UTC because it just confuses people. And you. Okay, so we see that this occurred at 8/13/84 on March the 5th. We go back over here. That's in military time. Okay, that's pretty close. That's pretty close. So we can say with a high degree of confidence that user John went searching for a rootkit, downloaded the rootkit to his home directory, and did some kind of install. Okay. There's some other things that you can do through Cabana here and Elasticsearch, but what I want to do is show. Now the question is, where did? Okay. Machine. Nope. Lost my virtual machines here.
I think you just went to the minimize bar.
Let's see. Let's go over here. Gotta love two mouses. Let's see, where did my, there we are. Okay. Okay. One of the things I said is that you can also output to a MySQL database. The MySQL gives you abilities to do some things that you can't really do with Elasticsearch and Cabana. They're very good for that initial review when you're looking at stuff. Now, and we want okay. I've loaded the timeline into MySQL. This will allow me to do some really fast searches and do some interesting stuff. Now this, of course, is not MySQL. What I've done is I've got it into MySQL and I've said, dump all the timeline. And I put this into a file so that I can scroll and search for stuff much more easily. So not quite. Jingyi Quan. And it's going to think about it for a while. That's the name of our rootkit. And we think about it and think about it. And while it's thinking about it, let's make this. Ah, there we are. Nine seconds after 8, that correlates well with what we got out of the SQLite browser. And we can see that all of this other stuff associated with, is it going to let me drag and highlight stuff? Yes, it is. Okay. There's the download. Places.SQLite, it got modified, so we can see that it changed. So we can see that that was when the thing got downloaded. Now let me search for that again. And are we thinking about it? Yes, okay. Search for it again. Ah, okay. Here we find some interesting activity. Yes, we know he downloaded it, but was anything happened after that? Well, look at this line up here where it says completions.tar. That means they typed the tar command and then hit tab to see what kind of completions they could get on the Jingyi Quan directory. And it's creating all of these files underneath there. So we have definitive proof that user John unloaded and unraveled the tar file.
Can we see that it was John that did that? I guess I had to have access to John's home directory.
Yeah, well, yeah, we will see that shortly. And yeah, it's going to go on for a while with that. So that's all on the 5th. He's unloaded it. Ah. Now we're up on the 9th. And notice this. Oops. Highlight. Running the more program on the README file. So now we're seeing that he's actually looking at how this program gets installed.
At least he actually reads the docs.
What's that? I'm sorry, what was the?
At least he actually reads the docs.
Yeah, I mean, you know, obviously this guy's a great system manager. He reads the README. He just doesn't go off and do this straight away. Yeah. Okay. What do we got interesting here? Oh, okay. Where am I?
Zingy root shell.
Yeah. mod.o. Ah, there's a created a file called Jingyi reverse shell. Now what we can do is we've got the image mounted, we got it mounted, so we can now start looking, seeing if those files are really there. Oh, now this is also interesting. Some point he loaded nmap. Well, you know, I'm a system manager kind of guy. Yeah, that's kind of a necessary thing to sort of have sometimes. So, okay, now, tell you what, let's do search wrapped. Okay, it's probably, where is it? Oh. What I'm looking for is, let's do that. Okay.
Try just install
Yep.
without the /.
Pardon?
Without the /. So it looks like it's got the full file path.
Oh, yeah. This may take too long. Tell you what. Did I spell it right? No. By the way, thanks to everybody for putting up with my typing. Think. Okay. That's where we got the tar. Downloads, all that good stuff. Make file. Okay, that's on the 5th.
You're looking for install, right?
Yeah.
Go up one page, it was there.
Yeah.
Oh, okay. Yeah, what I want to do, well, okay. Yeah, this isn't actually going to show that. Okay, we've seen that it's been downloaded, it's been compiled. Let me look at my crib notes briefly here. Okay. What about bash histories? Somebody, I think, mentioned that fact. Bash histories are good for stuff. Okay. Okay. Just a side point. An important thing is in these things is naming items. So picking a case number is frequently a very important thing, and there's no standard for it. But just pick something that you can relate to. This is the system name and the date that this investigation got started. There are,
One,
pardon?
you forgot a 1 in the name.
Sure did, thank you. There are 2 hard problems in computer science: cache coherency, naming things, off by 1 errors. Good. Everybody's still awake. That's good. Great. And actually, okay, we're collected. Now I can do something like star from HSTORAES. Rick, no.
You misspelled order?
Sure did. That's the French spelling. Order.
French sequel.
Ah, okay. This is going to give me all of the bash history for everybody's that's got a bash history, all the commands. That's not really terribly useful. Now let me do something. I did this ahead of time. More of the cooking show sort of thing. Okay. So that I don't have to get, I can do the typing faster. Okay. What if I want to see just John's history? And where is it? Oh, that's interesting. In maps the local host. Okay. CDs to downloads does an ls, does a CD up, CDs to home, does an ls clear, CD to download, ls, CDs to the Jingyi Quan. He reads the README file. He does sudo-s. He does an ls, a CD, nmap localhost, quit. Does some more stuff. Does some nsmodding. Does some more enter stuff. And looking at modules. This isn't what I'm really interested in. Ah, there we are. Goes back to the download, CDs to Jingyi Quan, does an ls, and does a sudo install. So he's installed the rootkit. So now that's all wonderful. Does sudo-s, becomes root, looks to see who's logged in, looks at Etsy password, sudo's to whoopsie, sudo's to lightdm. Interesting stuff. Let me see. Yep. Okay. What about that John N that got created? Typed W, catted Etsy password, tried to become whoopsie, tried to become lightdm. Great. The plot thickens. Actually, let me go back up. Go back to John. There's something I wanted to point out that I found. Where is it in here? Ah, here we are. Okay. Yeah. Exec bin bash. He adds username John N. Then he deletes it. Okay. Then he adds it back. Then he does something real strange. He CP's bin true to bin false. Okay. Think about what's happening here. Bin false is the default shell for most system accounts, so that if someone tries to log in, all it does is it returns a false value. and terminates. So what he's trying to do is he's trying to set up a back door. But he's setting up the back door wrong. Copying bin true to bin false isn't going to create a login that you can log into, because what's going to happen? He tries to log into it, it returns a true value, and then quits. That's not terribly useful. Then he realizes the error of his ways here. He creates a password for the system account whoopsie. He creates the password for LightDM. And then he realizes his mistake, and he copies bin bash to bin false. So now, any system account that he's created a password for, whoopsie and LightDM, he can log into as backdoors. Then he tries to edit group, and he goofs the path name. Easy enough. He edits the group, CDs to Etsy, LS is the group, cat's the password, CDs to home, does an LS. And now here's where he does a little bit of trickery. He moves John to .johnin, John in to .johnin, making it a hidden file. So if someone CDs to home and they just do a plain old ls or ls-ls, they're not going to see it. Then he does an ls, I guess, to make sure that this really did what he thought it did, and he does an ls-l to really make sure that he did. And then he edits Etsy password to do something. He looks up the man page for sed, and then he seds home John, and what he's doing is he's changing an Etsy password where John N's home directory is. And he does it through sed. Everyone see that? Then he realizes that doesn't quite work. So he says, okay, I'll put it in quotes. Now it'll work. Then he tails Etsy password, and then he does an install again and then maps a host. Neat stuff. We got some really good forensic evidence that user John is doing interesting stuff. He's creating bogus accounts. He's creating backdoors with system accounts, and he's downloading rootkits. Now, do I have this as a file already set up, or do I want to do... Oh, okay. Let's see. Let me go back over here to my crib sheet. If I want something that let me see how we're doing for time. Not doing good for time. Okay. Remember he copied bin bash to bin false? Since the file system is mounted, we can CD to that. We can ls bin and false in the bin directory that we've mounted. Look at the sizes. Sizes look the same. We can MD5 sum them to see if they are in fact the same file. This is just correlation generating further evidence. Now what I want to do here is look at some of the login information that's been captured in our database from the timeline. And we can see the logins of when things occurred. And let's see where, John N, okay, LightDM, system was rebooted. Where is it? Oh, how long they were logged in, but look at this. Remote logins from this other server. John is logged in from that machine there. system 192.168.56.1. John logged in, LightDM logged in, John logged in again. Interesting. We need to make sure we tell our client about this. There are two reasons why. One is just plain old ethics. The other one is that you can say to them, hey, I'm already doing a forensic analysis for you. I'll be happy to do this other machine for you for an add-on, extra money. Something a manager of mine told me many years ago when I was in the roving consultant game. Never leave money on the table. Okay. Since we are rapidly getting out of time here, let's... Okay, where's my mouse? Mouse, where's the mouse? Nope. Okay, this one, and let's go back to this. Okay, timestamps, Inodes, demo. Conclusions. John searched for and downloaded and installed a rootkit named Jingyiquan. I did some research on what Jingyiquan does. It's a rootkit that hides processes, it hides files, directories, network connections, creates backdoors, bad stuff. Go out to Packet Storm, you can download it and look at it. He created a username, John N, hid the name. He copied bin true to bin false and then realized this wasn't going to work. And then he copied bin bash over bin false so that system accounts that normally don't have that don't normally log in can log in as backdoors. He changed the password, created passwords for Whoopsie and LightDM. These normally don't have passwords. User John N logged in. He tried to become Whoopsie and LightDM, but this didn't work through an SU. I don't have that, didn't show you that, ran out of time. The reason why is that he forgot that John N has to be in Etsy sudoers to be able to do that. Conclusion, PFE1 is severely compromised. My recommendations, burn the thing down to the ground, start over. Get out the distribution media, apply all the relevant patches. Create a centralized syslog server that all the systems in your hybrid cloud log to, so that you have a centralized point so that you can do correlations and to prevent system managers that are really nefarious and start deleting stuff out of logs. Audit logging on root so that you have all the commands that root does logged into your syslog file. And finally, investigate this other IP address because it was used as a pivot point. Like I said, that's good ethics because you found this information. And the second one is enlightened self-interest. This may mean more money for you. Okay, I'm out of time. Sorry. Questions? Yes, sir.
Do you have any so it seems like the folks that are hiring you to come do this are folks that like need your help. Like, can you talk a little bit about how you tell the story of what this person did and like maybe some tips for? So how do you communicate to a customer that all of the stuff that this guy did is bad news and that he was like being like? Are you generally talking to people who know what a backdoor, like what it means to change the shell on a system user? That kind of
that depends. If you're doing, since this is in a corporate environment, odds are that you're going to be talking to system manager types. Hopefully, the user who is John is not in this meeting, but you never know. And you're going to be talking to lawyers. So you're going to be talking to the corporate lawyers because they may have, and HR, because they may wish to bring legal action against John. They may have grounds for dismissal also.
That's probably grounds for dismissal.
Yeah, I mean, this is unless the guy's, the CEO's brother-in-law.
Or he's a security guy.
Or, yeah, well, he's obviously not a real good security guy. But when you're dealing with the non-system manager types, you are going to have to do some level of explanation for the lawyers and the HR people. But it turns out that more and more lawyers in the corporate environment and prosecutors, public defenders, they're learning more and more stuff about this. So it's getting better. But yeah, you're going to have to explain some stuff to them about why this is bad. And that's just part of it. And the best way that I can give you 2 tips on how to do that. One is ask them what they know about. And if they, for instance, if you talk about a back door and you say, I don't know what a back door is, ask them, okay, do you have a house? Does it have a front door? Yes. Does it have a back door? Yes. Okay, the back door is an alternate way of entry, right? Yep, okay, yeah, okay, good. You understand back doors now. The other thing is draw a picture. Drawing a picture works really well if you can somehow draw a picture, because that makes the little light bulb over the head go on. But those are the 2 techniques that I use, is find out what they know and explain to them the concept in something that they know, and then draw pictures. Pictures really work well.
If you do diagrams, the more boxes and lines you have in your diagram, the more funding you can get.
The more what?
The more funding you can
Yeah. Speaking of that, as a word of advice, if you are presenting something to corporate types, if you can turn your graph, if you can make a pie chart, because corporate types understand pie charts, because pie charts mean food. They understand food really well. And if you can make it a pie chart, that works really well, because that they understand food so well. Yes, sir.
So how would you actually prove that John was sitting in the seat doing this rather than somebody else?
You can't. That's why through this I have tried to say user John, right, and not John. It is user John. Unless I'm standing over John's shoulder watching him type, I cannot prove that it was John.
Yeah, not even if he was sitting at the desk or anything.
Pardon?
Not even if he was sitting at the desk.
Well, in this particular case, since he's coming in, there are instances where they're pivoting off of another server. All bets are off there. All I can do.
What if that other IP wasn't another server? What if that was like John's desktop, though?
Again, it starts getting to be kind of very much a gray area, and this is where legal and HR come in, because you would want to get onto that workstation and see who was logged in at that time. If John was logged in at that time, well, it's probably a good bet that it was John typing it. But again, you weren't standing there watching it, so you don't know. You can merely infer that John was at his workstation and went to the server and did this. Yes.
It's not your job.
And it is not my job as a forensic examiner to prove that. My job as a forensic examiner is to the 5 W's and H, the who, what, when, where, and why. And all I can do is say that it was user John. I can't infer, I can, depending on the evidence and other things that are found out, yeah, I could infer that is, but I want to get away from from actually making the implication. That's up to HR and legal to decide whether or not it was really John. All I can do is present the best evidence that I can as to what occurred. And that's why a timeline is so important. Yes?
Your scope from the
Well-
company was not to prove it. Your scope
Yep.
was to determine if the server had been compromised.
Yeah, right. And that's also part, in part of the agreement, the service level agreement and the service level objectives. What are you agreeing to deliver to them? Well, obviously a report, but they wanted to find out, was the server breached? what was the nature of the breach, and something about the time. That's
And recommendations.
that, and recommendations, and we have a good set of recommendations there, which is just good best practices anyway on something like this. But a lot of what you deliver is dependent on those two things: the service level agreement on what you're going to do, and the service level objectives on what you're ultimately going to deliver.
Your job is not to prove.
No,
that-
yeah.
It could be me, Kathy, logging in with the account name John.
Yeah, it might be somebody that's stolen John's password.
Or they just popped open a root shell on John's computer because it wasn't encrypted and
Yeah.
he's got SSH.
Yeah.
Or as what happened to me, somebody jumped from my machine to another and then it
Yeah,
looked like it
pivoted
was
off.
me.
Yeah, the determination of guilt or innocence or anything like that, that's up to, in this case, since it's a corporate thing, that's up to HR and legal to decide. If this were, say, an instance of fraud involving credit cards, that is something that the jury in the criminal case would have to decide. And you were somebody was asking about presenting. How do you talk to these people? Talking to the jury so that they can understand some of this stuff. That becomes really critical in your part as a forensic examiner, is being able to explain why is a rootkit bad. And you might actually have to do a demo of that particular rootkit for why it is bad to them. That is a real possibility. That's also a real possibility in the corporate world too. Yeah, it's.
One thing you might have looked at is what is the corporate acceptable use policy?
Yeah, now.
Hopefully you have one.
Well, hopefully you do have one. Now, it may be that John may be the system manager, and he may be the brother-in-law of the CEO, and he says, well, I was experimenting with this rootkit so I could find out how it works. Well, that's kind of a lame excuse, because that's what VMs are for, not corporate servers. But yeah.
And is he authorized to have that software on his desk?
You know, some places just having Nmap alone, that's bad. But searching for a rootkit, downloading the rootkit, well, you know, searching for a rootkit, well, that's kind of bad. Downloading the rootkit, well, that's not real great. Compiling the rootkit, well, that's really not so good. But then typing /install, not good. That is really not good. That gets around any idea of acceptable use. Okay.
Thank you very much.
Thank you all for coming.